Hello, class. Let's do a sample calculation here for each of the kinds of problems that you have to do. So for the first table here, we have the x component at 100 grams and the y component at 60 grams. We use grams instead of forces in this lab because it is going to, when you look at the angles, we're going to be looking at the ratios anyway, so that would be fine. We can convert it to mass forces by multiplying by the force of gravity each time, because all of these masses are hanging from a pulley. Assuming that the force of friction of those pulleys is 0. Anyway, so we can use either grams or masses or forces. It wouldn't matter. We have here we're doing the sample calculation for the first problem, which is right here. 100 grams on the x-axis and 60 grams on the y-axis, and we need to find the resultant vector, which gives you the opposite of the equivalent force. So when you are adding vectors, of course, don't remember that head to tail. So the resultant vector is going to be in this direction, which is from the head of the first vector to the tail, till the first vector to the head of the last vector that you have. So it's going to be in this direction. To find the magnitude of this vector, we can use the Pythagorean theorem. So you have 60 squared plus 100 squared, and you take the square root of that. That's going to be your resultant. So the magnitude, so computed magnitude. So I'm going to put CM for computed magnitude. That will be 3600 plus 10,000 and under the square root. The reason why I wrote this way is because the significant digits here are the up to the 100, not 100. So the ones and the tens are not significant. So when you add them up, you're gonna end up with 136,000, and those are all significant. So you're taking the square root of 136, I would take 136, 13,600. You take the square root of this number, and you end up with 116.69, and that rounds off to 117 grams. Okay, so this is your computed magnitude, is 117 grams. Okay, so we go here. That's one thing. And now if you are looking at the magnitude, so if you continue this the same distance in direction, so its angle here is 180 degrees. So how do you this angle? So what you need to do in this angle first, and then add 180 degrees to it. So find the opposite, which is the opposite grams. So that's the same as this one right here. Okay, so 60 grams. So to find the angle, you call this angle theta. So inverse. The reason why I'm